Thank you for using GL Sciences products. This video discusses HPLC column troubleshooting concerning reproducibility issues between columns. There are many causes. This time we will focus on lot-to-lot variation. First, we would like to discuss the different kind of problems you might experience when changing columns. Have you ever experienced getting different results when using a new column? For example, the retention time is different between the previous column and the new column. There are multiple causes and they can be difficult to identify. There are 4 relatively common causes concerning inquiries we receive. First is lot-to-lot variation. Second is low robustness conditions such as mobile phase pH. Third is not enough time taken for column equilibration. Last is secondary interactions such as silanol interactions. This presentation will discuss the column equilibration issue. Column equilibration is required when you start using a new column. Many of our new reversed phase columns are shipped with a water acetonitrile ratio of 35 versus 65. This can be different from the conditions you need to use the column with. After having done a long enough equilibration, the chromatograms are expected to look very similar. The chromatogram has a good peak shape and retention times are reproducible. Shown here is an example of a chromatogram analyzed without enough equilibration time. As can be seen, the mobile phase used with this application is different from the one at the time of shipment. Not having equilibrated the column long enough results in poor peak shape and bad reproducibility of retention time. The second case is equilibration for applications that use a gradient method. In case of a gradient method, the composition of the mobile phase changes during the analysis. It is required to finish with the initial mobile phase condition after eluting compounds. In this example, gradient analysis is running between 5 and 12 minutes, then equilibration is starting with the initial composition from 12.1 minutes. The equilibration time is the time to run with the initial composition, after 12.1 minutes in this case. If equilibration time is not long enough, the chromatogram peak has a poor shape and low reproducibility of the retention time. The effect of not having equilibrated long enough is a faster retention time. This is undesirable, making your chromatography less reliable. We will now elaborate on why it is important to equilibrate a column long enough. When you start using your new column, you first need to flush the inside of the column with your mobile phase. In many cases the storage solvent has a different composition compared to the mobile phase to be used. Replacing the mobile phase with some storage solvent does require some time. You may think that the storage solvent will be replaced by the mobile phase when running a single column volume. Actually, it is necessary to run several times the column volume. We advise to run the column volume 10 times or more before using your new column. A column packing material such as C18 has many pores and a large surface area. The storage solvent is not replaced in every gap between the functional groups after running the mobile phase. After running the mobile phase, the storage solvent is gradually replaced within the silica particles. It requires time for the replacement of the solvent to be complete. In case of gradient analysis, the meaning of equilibration time is the same as previously explained. But the difference is that in this case, every analytical run requires equilibration time. When comparing between C18 columns, the equilibration time can differ between brands or even C18 column types within a certain brand. We will explain this later in the presentation. Now we will explain the method of column equilibration. When using a new column, it is often sufficient to flow the initial mobile phase for 10 times the column volume. If you use the column in ionic conditions such as an ion pair reagents, you need to run more column volumes. The column volume can be calculated by the formula shown here. The column volume of typical columns are shown. Please refer to this page. Calculating the running time from the column volume can be a tedious job. A rule of thumb is to equilibrate 1 minute per 10 mm column length. For a 15 cm length column that would be 15 minutes, for a 25 cm length column 25 minutes. In case of a gradient mobile phase analysis, every analysis needs to be followed by an equilibration. However, if you apply 10 times the column volume for equilibration, equilibration becomes a substantial part of the analysis time. Despite having such an impact on your chromatography, it is not wise to shorten the equilibration time. But it may be possible to shorten equilibration time by choosing a different column. For example, we compare the columns with different carbon loading and surface area, under the conditions shown here. The carbon loading and surface area values are published by most column manufacturers. The two cases on the left have a similar surface area but the carbon loading is different. 9% versus 18%. The two cases on the right have a similar carbon loading but the surface areas are different. 185 square meter per gram versus 340 square meter per gram. After running 3 times the column volume for equilibration, the chromatograms look like shown here. The left column with a low carbon loading and a small surface area has the least baseline wave. The currently shown chromatograms are the result after equilibrating 6 times the column volume. The two small surface area columns on the left are almost equilibrated. We conclude that the equilibration time of columns with a small surface area is faster. After running 10 times the column volume, the last chromatogram column is also equilibrated. With a carbon loading of 17% and a surface area of 340 square meter per gram, this last column is also the most common column shown. Therefore a typical HPLC column requires 10 times the column volume for equilibration. Having shown columns that can handle a shorter equilibration time, there are also columns or methods that require a longer equilibration time. Here we show some examples. Especially for a new column, it is wise to extend the equilibration time when running such method. We also recommend to avoid using a gradient for these methods. When you do have to run a gradient, a long equilibration is required for each analysis. Thank you for listening. If there are any questions, please feel free to contact us again or visit our website for support.